Hello everyone, how are you? I hope you are doing well. Today is our lecture 2 of machine learning and we will discuss overview of all types of machine learning and also we discuss the basic flow to train and evaluate the machine learning models. In previous lecture, we discussed in detail introduction to machine learning and we also discussed the main objective of this course. I hope everything is clear to all of you. If you have any query, please feel free to ask me. Then we move forward to our lecture 2 of machine learning. As we discussed earlier in our first lecture, the main uh, objective of this machine learning course is to give you as possible as more information about all components, all resources of machine learning, and I will try to cover all important concepts of machine learning in this course. Let me share my screen. Oh, sorry. Let me show. Okay, today's lecture 2 types of machine learning and its basic flow. There are three mainly types of machine learning. First one is supervised learning, second is unsupervised learning, and third is reinforcement learning. We will discuss each of type in detail with real-world examples and implementations and all important concepts about these types and where we will use these types of machine learning in real life scenarios. So let's discuss first type of machine learning, supervised learning. It is about labeled data. If I uh, talk about supervised learning, then there will be data in labeled, which data we will use to train our model. It will be in labeled. There will be any uh, category, there will be any class and names of data. Like here you can see there are three types of animals and we labeled name of each animal in our training data. Then we train our model on the labeled data. For example, we train our child, our son, and we give them, give him uh, labeled data. For example, we uh, told him, we trained him that this is cat, this is dog, and this is another bird. When we give a new same shape of data, then our child will predict that it is dog or cat or any other bird. Similarly, supervised learning models are working same. We use paired inputs and outputs, which has labeled data. It learn from the patterns, then predict new data. For example, we trained our model on labeled data. We gave our model the names of animals like cats, dogs, and other. Then it predict We when we test our model, it is performing well or not. We give our model unlabeled data to test the accuracy of our model. If our model predict correctly, then its performance is good, its accuracy is fine. Like we give our model to test some unlabeled test data like all, cat, and dog, and it predict correctly like it is all, it is fox, it is squirrel. Then it is this type of models are supervised learning of machine learning. Another example of fruits, like we train our model with labeled fruit images. We talk to our model that it is orange, it is apple, it is pineapple, it is banana. After training our model, we classify and give we test our model with new fruit images without any label to predict the output accuracy and to predict the name of these fruit images. Keep in mind that in supervised learning, we trained our model with labeled data. Some important applications we see in our real life are spam filtering, like we want to classify, we want to know which email is spam category or non-spam category. We want to check which email violates some rules. Then how we perform this task in supervised learning, as we said that we use we discuss some parameters, we discuss some important uh, instructions to our model, and we gave them some label to them. For example, we discussed our model that if this type of text matches, for example, in text he find, oh, you won the lottery of $10 million. This type of labels, we trained our model on these types of labeled data to classify, to predict the outcomes. Next application is speech recognition. For example, you talk to ChatGPT, there is a mm, microphone, and you talk in audio. Then it converts to text. This is another good example of supervised learning. It dictates your audio to text. Next important application, machine translation. For example, you say you write hello world in computer, but your machine cannot know what is hello world. For example, you said hello world in English, but your machine uh, understand uh, French language. Then this conversion, this translation is another example of supervised learning. Similarly, online advertisement predicting ad clicks. For example, if you are advertising any product and customer click on that, to track these clicks, to track these advertisements, to make analysis and prediction and recommendation systems, we use supervised learning. Another most important and latest use of supervised learning is self-driving car. As you are now seeing Tesla, which is using radars and satellite system and self-driving, it all are applications of supervised learning. Last but not the least, visual inspection. For example, detecting product defects. We want to analyze any bugs, any defects in the production of any product. Then supervised learning labeled data will assist us because we are using labeled data in training phase of our model. Then it is very easier to detect the defects in our product or model. Let's move forward to supervised learning types. The two main important types of supervised learning are: first one is classification, second is regression. As name suggests, classification means we have two possible things, like we have predefined labeled data and we categorized these data into things. For example, email is spam or not, customer has disease or not. On the other hand, regression, predicting continuous value. For example, you can see in this image, there are inputs and these are continuous values. For example, user give continuous inputs and we are predicting the outcomes on the basis of these inputs. For example, house pricing, user give house location, house size, and house uh, house decoration or other important features to predict what will be the price of this type of house. Similarly, another most important example of regression is future sales. We want to know which product is more likely to be buy from the customers, and these types of customers like this type of product. On the basis of input data, on the basis of continuous values, we change our decisions, we make our decisions to improve our sales of this product. This all happen in regression. Let's uh, talk about types of classification. There are multiple types of classification, but here I will discuss binary classification and multi-class classification. These two classifications are mainly two types of classifications. Binary classifications mean we have two possible outcomes. It means yes or no, true or false, spam or non-spam. As you can see in this image, we have two categories like it is cat, it is dog. Okay, right? Multi-class classification means when we have more than two outcomes. For example, uh, on the basis of age, the outcomes are uh, child, young, adult, yeah, or elderly persons. Okay, these types of classification is multi-class classification. Common supervised learning algorithms are KNN, support vector machines, linear regression, logistic regression, Bayesian tree, and random forest. We will discuss in this machine learning course journey each uh, algorithm in detail. We will also discuss the practical implementation of each algorithm in later section. Okay, next is second type, unsupervised learning. Unsupervised means unlabeled data. We have data without any labels and we train our model without any labeled data. Okay, model identifies the main patterns, the main features, and group them uh, into similar data points. For example, we train our model on unlabeled data, then how it will uh, learn the patterns and identifies the pattern. It will see the features. It will, for example, we testing our child, tell me what is this animal or what is this. Okay, how the child will proceed. He will see the data features, for example, data attributes, for example, its color, its size, its quantity, and its category. Okay, then on these similar faces, these types of data points, he group them. This type, this grouping is also called This method is also called clustering. We group the data on the similar data points, on the similar features to predict the outcomes. Applications of unsupervised learning. As we said that clustering method about grouping on the basis of similar data points. Okay, second is dimensionality reduction. It is very important concept in data mining and machine learning because when we are doing data pre-processing, then we have unnecessary data in our data set and which affect the accuracy of our model. To remove this useless data while retaining the important features. For example, we want features, but we remove the useless data to improve the performance and accuracy of our model. This concept is dimensionality reduction. Okay. Third is anomaly detection. You can see here and here P1, P2 are red colors and they are far from black dots. What does it mean? These are outliers. For example, in a room, there are 99% of white color and one is black color and he is sitting far from 99 percent. Then it is like an error. It is like an outlier. It shows unusual behavior. Okay, let's talk about its real world example. For example, fraud detection. For instance, we want to classify this customer will be in fraud list or not. This customer have history to do fraud with bank or not. Okay, some other common unsupervised learning algorithms are k-mean clustering, DD-scan, hierarchical clustering. Again, I will discuss all these types of algorithms in detail in our upcoming lectures. Principal component analysis, one class SVM. Okay, last one is third important type of machine learning is reinforcement learning. As name is showing that reinforce, like we are enforce our model to do some particular task. Okay, you can see this image. Okay, what you can predict, what you can observe this. For example, a boy, there is environment, a boy, and there is your model agent. And boy said to model that please jump and pick the ball and return it to me. If your agent will do as same as task, as you wish, as you asked, as you demand, then what you will do? You will be happy and give him reward on the basis of its action. Okay, here dog, which is agent, learn from interacting with environment, which is your boy. Okay, if dog do not complete the task and you observe that the dog is not completing the task, and how will be your reaction? You will be angry and you will do penalty, you will do punish to your agent. When your agent observe that on his action, on its action, my environment or my owner is punishing me, it means I am doing something wrong. I need to change something. I need to observe more action to perform very well to get reward. These types of learning we are these types of environment and scenarios we are discussing are example of reinforcement learning. Okay, as in previous image I showed the mechanism how it's work, how the process of reinforcement learning works, and a continuous cycle of interaction. First, action, like the agent performed action jumping and catching the ball. Then agent perceive the environment. For example, if we agent is doing well and according to its environment, and the environment is giving him its reward, then it will observe that I am doing something good on the basis of observation, on the basis of feedback. Okay, if agent is not doing uh, good and not performing tasks as its environment demand, then the feedback of punishing and penalty from penalty, the agent will perceive, observe that I am doing something wrong, I need to adjust something. I hope you understand the concepts of reinforcement learning as simple as I try to deliver to you. Still, if you have any query, if you have any question about what is in reinforcement learning, and you want any other example, I am here to teach you, to instruct you, and to give you more real world example to better understand the concept of reinforcement learning, the application of reinforcement learning in real life. Right, let's move forward. Now I am discussing about common algorithms uh, as we discussed some algorithms of supervised learning. Then we discussed algorithms of unsupervised learning. Here are third type of uh, learning algorithms, which are Q learning, SRS, SARSA, Deep Q network, policy gradient methods. Okay, don't worry. Now just see the names and see definitions only. We will discuss each of algorithms in our upcoming classes with practical implementations and where we will use these types of algorithms, these types of models we will make in future. Okay, most important concept we will have to keep in mind the workflow of making any machine learning model. First step we do to identify the problem which we want to solve. Okay, then we find the data about the problem. Then we identify which data we will use for training purpose and which we will use for testing purpose. Okay, data collection. But when we collect the data, when we receive data, we gather some data. The data is not clean, it is raw data, and we need to clean and format data which will be compatible to our model, which will be easier for our model to interpret, to manipulate this data. We will do some types of operations to clean, to format, to visualize this type of data. This all process is include in data pre-processing step. Third is model selection. On the basis of data, on the basis of problem, on the basis of our machine learning model performance accuracy, we compare, we use best ML algorithm from supervised learning, unsupervised learning algorithms, or reinforcement learning algorithms. Our main goal is to maximize the accuracy of machine learning model, which we are trying to make it. Fourth step important, training the data using the training data set. Then fifth step is evaluating when we train a model on basis of some data. Then we want to evaluate how it will perform on the unknown data, on test data. This step is covering evaluation. We will see confusion matrix, we will see uh, classification report, we will see F score, Z score, and other important factors in evaluation of machine learning model step. Fourth one is your model is ready. You trained a model, you evaluate the model performance, but it is still on your local machine. You want to deploy it somewhere, okay? You want to integrate it with any uh, SaaS application or any other application